Well, hello. We're here for talking about Docker today. So we'll get a chance to talk about Docker and .NET and containers, and we'll jump right in. So
awesome.
You are?
I am.
The same person you were before?
The same person I was this morning, funnily enough. My name is Glenn Condren. I work on a lot of ASP.NET stuff. I've been working on what is ASP.NET Core from very close to when we first started actually doing prototypes of this thing called Project K. Today, I'm mostly here to talk to Steve, as Steve does a whole bunch of stuff. I'm also going to be on Twitter, so if you guys are asking questions and you can tweeting me, then while Steve is doing a demo, then I may be able to answer some of them, and I'll definitely answer them later on as we go, so feel free to do that. But we might not actually call out questions during the talk, because there's a whole heap of content to get through.
Yeah, so I'm Steve Lasker. I work on our Docker developer story with .NET, Node, and the Azure Container Service, and VSTS, and some other efforts as well. So we're going to have fun talking to you today about this. One of the things we wanted to do is kind of take a bit of a step back, because we often get very involved with Docker and think of all the cool things it can do. But at a conference like this, we often get asked, like, well, why containers in the first place? And it was
yeah, we kind of want to break the talk up into two parts and say, for those of you who don't know anything about Docker, let's talk about, or containers more generally, let's talk about containers for a bit and get you some understanding of why containers are cool, as well as learning a bunch about general container stuff. And then talk about some specific, like, .NET Visual Studio container facts. Yeah, that makes sense.
So one of the things that was kind of interesting is, is this evolution of stuff. And we often get asked, what about VMs, and how does this compare to VMs? Is it just a better VM? And I kind of think of it as a car, a better horse. I mean, there's fundamental differences that evolved, but things have to fall in place. So very much like each one of these things that has evolved over time, from light bulbs to an LED, or this steam engine to a pretty cool engine, or motors or batteries. With all of this, we could actually get, really cool steam-powered motorcycle.
Yeah, that's pretty cool.
That'd be pretty. It wouldn't be very cool. It'd be pretty hot, actually. But maybe riding around in the winter wouldn't be so bad. But a better example of that might be, the Tesla car, for instance. If we try to drive that with halogen light bulbs, we probably wouldn't get the range that we do today. So everything from lightweight plastics and lightweight metal and everything, or just flying that helicopter around. I used to fly this big helicopter around when I was younger, and it was massive to carry this engine, and would do damage wherever it landed, and didn't usually land well. But now you're flying around in a mall, so a lot of things had to fall in place for it to change.
So what we're saying here with the analogy is that the containers are kind of an evolution of a whole bunch of little technologies that have come together to form what we can do today.
Right. So, and similar in a container world, before there was container standards, just loading ships with packages was a pretty significant effort, right? We had this whole industry of stevedores, and ports were much bigger because it took longer to load ships, or how to even get them from point A to point B, the number of times they had to move from one thing to another, because they're always being loaded in a different box, a different container, a different truck. And that was a very laborious, timely, and fragile process, as we could kind of think about when we're deploying apps sometimes.
Yeah, absolutely.
So shipping containers were invented quite a while ago. The interesting stat here is not only the time that it's been now since these things were invented, but look at the costs. I mean, it was like $5.86 a ton to load at that point, and they got them down to 16 cents a ton. And part of that had to do with the reliability, the speed, but the fundamental industry, as we know, changed, right? You can just change the way people think about shipping now. And that's the way we look at containers. I actually, while we think about the orchestration systems that we'll talk about today, we think about containers probably being the new binary of deployment. So that's an interesting.
So if we take that analogy back, like with what you were just saying, is just as historically you had specialized ships that you had to have people who knew how to take all the different cargoes and put them into the ship and take them around, and then you needed someone on the other end that knew how to take the cargo out of the ship and put it on the docks. And you've changed that from to shipping containers, where all the ships are standard, you just put a container on, it doesn't matter what's in it. And when you take that to computing, what that means is now instead of having like this special custom-built computer, like server that knows how to handle my .NET
Somebody has to give a whole bunch of
applications.
information. Here's what I need to host
Yeah.
this app this week.
Yeah, so now you containerize your app, and all your server needs to know about is how to handle a container, and then I put my container on the server, and away it goes.
Right. And who cares what's in it? Could be .NET, could be Java, could be whatever. It could be MVC, could be .NET RC1, RC2.
Yeah.
They all can sit side by side, and they don't care. I need to run this container. Taking that theme forward for a manifest, what we want to kind of drill into is the bigger picture, not just Docker run. We wanted to put this in context of how people would use the apps overall. And as we'll see, there's quite a bit of vocabulary that can be kind of confusing, and we'll drill down into architecture and containerizations in .NET Core and how to actually develop and deploy these. So a lot of stuff to cover. Which kind of brings us to our point. There is a lot of stuff to cover, so we're going to kind of skim across the surface. There'll be some cool features in here that we'll highlight with some baby stingrays, which is kind of cool. And there'll be some sharks along the way that you might like sharks. That might be your thing. But we'll highlight those just to touch on them.
So baby stingrays are when you've gone a bit deeper, and sharks are where you've gone deeper into something that can be a little bit hard or dangerous. Is that what it is?
Yeah, cool and dangerous.
Okay.
But some people like dangerous.
Well, that's fine. Okay.
So there's a lot of vocabulary. I'm not going to try to describe them all here, but we're going to put some context to all these because, anytime you get involved with a new stack, it becomes very overwhelming. Should have taken, shipping as a language, sailing as a language when a kid, or now with containers, there's a lot to take on as well. So first of all, let's just kind of reference this back to VMs because that's the most popular question that comes up. Like, isn't this just another VM? So in the VM world, we have our host hardware, and of course you have an OS on there. And then we have the hypervisor. And then you can actually put your VM on there, the guest VM. And in that, you can put a set of apps as long as they work within that environment. Right? And we unfortunately know about conflicts that we can put on machines, and we're doing things with .NET Core to make it better, but that still has been a problem. Now, on another OS, on that same physical hardware, imagine now you can install this thing called the Docker daemon, and now I can run all sorts of containers on there. And that isolation that you get gives you the isolation you need from an app model, but I don't have to take the entire OS with me.
So it's not as isolated, right?
It's not as isolated as a VM, but from a process and from your app model, it gives you the isolation you need.
Yeah.
And we're actually doing some pretty cool things here with Windows containers as well. I mean, this is the general concept of containers. And with Windows containers, we have something called Hyper-V containers, which is more isolation around that as well.
So I think the analogy that I liked when we were talking about this was the kind of a house versus an apartment building kind of thing, where a VM is like where you've got a house with a yard and a fence and locked doors, and it's just you inside of it, and everything is completely yours. There's nothing
and I have my
shared.
own lawnmower. I got to deal with that. My own heater.
Everything is yours, right?
Yeah.
Versus the kind of apartment complex, apartment building model where you've got a room inside an apartment building, you have a bunch of shared, you're still separated from everybody else.
Still got my own kitchen.
Yeah, you got your own kitchen, but you've got a bunch of shared infrastructure. You have a bunch of guys fixing things, you have maybe shared heating, shared internet, maybe something like that. And that's kind of the analogy that you make. And then there's like kind of some steps in the middle that Windows containers do.
Yeah.
But it's just like not still isolated enough, but faster and more dense.
Maybe Windows containers are like insulated walls or something.
Maybe.
It's probably some stupid analogy that I probably just got yelled at for. Very cool. This is one of our very cool stingrays, is that think of the density, the number of things that you can run. And to your analogy, there is some shared stuff, right? Without going too deep here, it's not that they did anything magical, it's that they've offloaded core parts of the OS to the host, and they're sharing parts of the operating system in here. So good point to jump on. So let's get to our first demo here. What we're going to do is, I'm in a PowerShell prompt. We'll show a little bit reason why PowerShell versus a command in a moment, but I'm just going to do the most basic of Docker run BusyBox. This is an image, and you'll notice that the first thing is, though, it doesn't have it locally, so it goes out and gets it, and that's this pull complete thing. And it literally downloaded it off the internet, ran it, started it up, ran it, executed, and it's already done. In fact, I can run it again, and this time I'll keep it in interactive mode. Started that quickly. I can list the contents. I can list the contents and run a container. I can't figure out how to change the color, but that's something else. And now I'm in that container that quickly. And if I say Docker PS, we'll see that it's not running anymore.
Right. So you were just running, when you're inside your container, you're in a Linux world, but even though you're in PowerShell on a Windows machine.
Right.
In this case.
And we'll drill into that a little bit more. But that's the basic concept.
Right.
So now you might wonder, where did BusyBox come from?
Where did BusyBox come from,
That's
Steve?
right. It was busy.
Yeah.
It was on another box. So Docker has the concept of a registry, or a Docker hub. And there's the public registry, kind of like there's the public GitHub accounts. And anybody can put images up there. And that's where you can get to like public images. That's where we're putting ASP.NET or .NET. And Windows has a bunch of containers up there too. In fact, we'll see that in a minute here. In fact, why don't we just do that demo here? So I can do, from the command line, I can do a Docker search for Microsoft. And now it'll spit out all of the images it's found that are Microsoft. And you mentioned before, like here's a .NET 3.5.
Yeah.
So what, obviously
I know
that's...
.NET doesn't work on Linux at the
Right.
moment, right? Like not .NET 3.5.
So what we have is we have a Windows container there. This is part of the partnership we've been working closely with Docker on, where we have Windows images in the registry as well. And some of the multi-platform support that they're doing, Docker is doing, is going to be pretty cool, because you can have a single image name and have the Linux and the Windows version of it, and it'll know based on the host that you're calling it from to give you that version. It's not all complete yet, so the UI is a little confusing at this point, but it will. You're seeing work in progress.
So what we're kind of saying is all these images, all these names in here, the Microsoft/.NET, contains inside of it all of the files required to run in this case, I think that's a Linux image, but I need a Linux-based .NET container.
Correct. And there's a sub part of it too called tags, which are different variations of that image, and we'll drill in very deeply into that one, very shallow rather.
Yeah.
So the Docker API, kind of give an idea of the workflow of how this works. So it actually works as client server. We still have these technologies around.
Yep.
So when you issue a Docker pull, what it'll look is, if you notice in the center here, there's a host with an image cache and the running containers. So it didn't have one locally, so it went out to the registry, in this case the public registry, because I don't have a private one configured, and said, okay, I'm going to go get that. And then when I say Docker run, it will instance that image. And if run doesn't find one, it'll do the pull implicitly.
Right. So the difference between an image and my container is that an image is like my class definition, and my container is my instance of said class.
The instance of it.
And I could have multiple instances for a single image.
Exactly. So back to our little test we'll do here. We have run, search, pull. These are some of the commands that we're starting to put into context now in our examples. All right, so we've posted an image. We had an image out there. We pulled it locally. We ran it. Well, how do you build images in the first place? So let's go do this with .NET. Let's see. Let's clear out where we are. And we'll get into a hello world directory. And if we look, oh, actually we do have.
This directory was supposed to be empty, I believe.
Let's make it empty. Yeah,
Okay.
it was empty.
All right.
See?
Yeah, look at
That
that.
quick.
It's empty,
right?
yeah.
Okay, so what we're going to do is we'll open this up in VS Code, and we'll see that it is empty now, because that's not really there. But now I can use the .NET CLI, and we'll say .NET new. Now I'm doing this very purposely at a command line and with VS Code. Of course, we have great Visual Studio integration. I just wanted to show the more primitives of what's actually happening here.
Okay.
So notice we now have program CS and our project JSON file here. And so what we can do is, now that we have that, we can actually start doing a build of that. But to do a Docker build, we need a definition of how to build the Docker file. So we'll come over here, and we'll save this as a Docker file.
Yep.
And by saving it, we actually have some language syntax in here. So now I could start to say from Microsoft .NET. And I want an optimized image in this case, because we're actually going to build this with DLLs. So what we want to do is say from Microsoft.NET 1.0.0.
So what you're doing here as you type is you are choosing the base, the .NET base, so that it just knows enough to be able to run an already built application. There's not enough inside this container to build an application.
Correct. We really want an optimized image. We want, there's actually two different types of images. There's images you want during development, which we'll show later on. And there's optimized images you want for deployment, because when you're running your containers into production, you want it to be really fast, start up really fast, be as small as possible so they can run across the network and get lots of great density. So that is the base image we're going to build from. And then I need to set the working directory, and I'm just going to set it to app. Okay. So that's the directory inside of that container. And what we're going to do is copy from app on my host machine to the app directory within the container. Now you notice I don't have an app directory on my host. We'll get to that in a minute. And then lastly, we need to tell it what's the entry point. When the container starts up, what does it do? It's not, this is the interesting thing about containers, is don't think of it as a Windows server where it's got like lots of services running. You're starting it, it knows what to do, which in Windows you can do that as well. This is really task-oriented processing. So now I'm going to say I actually want to start with .NET, and I'm going to say start my Hello World DLL. That's going to be the entry point once I've done building this.
So this is the same stuff you would run on the command line if you were to run an app. Like I think I showed doing this on the command line earlier on in my talk.
All right, so now that we've got that, we'll do a .NET restore just to make sure we've got all the packages. It's a pretty small app, so it probably isn't really a problem, but just to repeat when you've done something a little more complex. Then we're going to do a .NET build, which technically isn't required, but we're going to walk through the steps anyway, for the release environment, and we'll build that. So notice we now have a bin folder that just showed up. And now I can say .NET publish, release, and here is where I'm going to get the app directory. Now, .NET Publish actually does a build implicitly, but we just showed it for completeness.
Okay.
So now, if we look what we've got.
Right, we have an app folder that we can copy into a
why do I got a
container.
PDB in here? Always. Anyway. All right, we'll work on the slimness of things in a bit. So now I've got this. Now I've got my app built, but now I need to do my Docker build. Docker build. We'll tag it with an image name. Hello world, all in lowercase.
So you know, this is the word that you type later to run the thing, right?
Right, so I'm going to name this. I'm going to build something, and I get a chance to name it, and I tell it dot to have the context, and it looks for something called Docker file. I could pass it a flag. That's what I was afraid of. Let's see, Docker file, Microsoft.NET 100.
You don't have this.
Oh, sorry. Too many, I'm not even going to say what that is. Let's just do that again. And now get an example why we need good tooling. So we'll get to that. So we built the image, and now we have it. Now if we do a Docker images, we'll see in this long list, we have the Hello World built 10 seconds ago. But if we say Docker PS, we of course don't have anything running.
You haven't actually ran this container yet. You've just made it. You've built it.
So if we run Hello World,
we've
just done it.
Amazing.
Amazing. Wow, we've done Hello World. Now, the thing is, it didn't run a process. It ran an entire container, right? It spun up that entire environment, ran that, and shut down.
So you're on a Windows machine. You've just compiled an .NET application. And then you've copied it into an image. You've built an image with that application inside of it, and then run it on a Linux machine.
Yeah, on my Windows machine, I'm running it in Linux.
And it just started instantly, and it ran instantly because the host is already running. You don't need to start it up again. So all that boot time of my machine is gone. It's just like starting up and closing a process, except I've got all this much better isolation.
Right, I got the whole environment with me.
Yeah, and in that Docker file, as Steve is typing in some stuff that he's going to explain in a minute, inside his Docker file, he could have done things like install something. Right, he could have done like apt-get install some dependency that my application requires, and then that would have been there ready for my application to consume. So you can kind of define your environment and make sure that when you get to your production environment, that file or that package that needs to be installed or that file that has to be there is always there, because you defined it as part of your Docker file, your build environment.
Right, so I don't have to hand a document to somebody that says, go build the environment for this and please don't forget something or make sure I don't forget it. I can actually define that and test it myself.
Yeah.
So what I've done here is we're going to do a little bit of tweak to this and tell it to run for 30 seconds and just keep on spitting out hello world. So we're going to go and build this again. Actually, we can just say publish and it'll do the build for us. And then we'll say a Docker build. I keep on forgetting to tag that. Loop, so we'll have that. And then I could say Docker run hello world loop. And if I do it here interactively, not interactively, but just running it, notice it's spitting it out one at a time.
Right.
And if I do a Docker PS, we could see it
It's going.
still running.
Right. And then presumably after like whatever, what did you say, 30 seconds or 15 seconds or something?
I think I did do 30. I meant to do 15.
So after 30 seconds, that thing will go away once it's finished doing its thing. Cool. So you're going to publish again, or you're going to reduce the time?
Yeah, because I'm not sure which is faster at this point, so we'll do it this way. So now if just to show how fast we can do these, let's do Docker run again, hello world, but I'm going to launch it and tell it to detach. And I'm just going to do that several times. So just as you were saying before, I've now instanced kind of a bunch of classes, and I am running a bunch of these at the same time. So imagine I've spun up a bunch of processes I'm trying to scale across multiple servers, or I'm trying to have them individually do separate tasks, and I pass parameters to them, and notice they're already gone. So that's pretty cool. I mean, that's something that you don't think about with Windows, starting up a Windows server, doing a job and having it shut down in a clean state each time.
Yeah, every time. So each one of those, if you would like change the file in the first, like an OS file, say, inside your container there, it only would have changed it for the instance that was running. It doesn't change it for all. It's sort of kind of a, well, when we talk about file system layers later, maybe we can talk more about that.
Well, that's a great example, because right, I mean, how many times we've got something running and it dies because a log filled up and polluted it, or some kind of damage happened that we just didn't
know that
intend.
every time you start a new instance, it's exactly the same as it was the first time.
It's clean.
Yeah.
So how does all of this run visually? Let's take another quick look at this. The client, we say .NET Docker build. We've already done the .NET stuff. Somebody covered that earlier, probably might have been you. And we pull the .NET image there. And then it starts building our new image. We're putting the content of our Hello World DLL in it, because it's the copy app. And then when we say Docker run, it will instance the image we just built, which we named Hello World in that case. And then if I want to get it off my machine, I would do a push. So let's do that really quick. To do a push, we need to actually name it something. Like if I just, where am I pushing it to? So Docker has this convention here, and we'll say Docker tag, hello world, and we said loop, right? And I'm going to tag it Steve Lasker, hello world.
Right, so Docker has a convention similar to like GitHub, where you need a repo name and then a thing inside the repo name. You need like your username, then your repo name, and then your thing, right? Yeah.
So now I could say Docker push, and because I've already tagged it that way, it's going to push it up into.
Right. So it's going to find the hello world, the Steve Lasker user on Docker Hub, public Docker Hub on the internet, and it's going to take your application and it's going to upload it, your application's image, and it's going to upload it to that central repository in the sky.
And notice that a bunch of these things said layers already exist, right? It only had to push that last piece of Delta information. So let's take a look here. If we look.
Cool. So you have your .NET Conf a few seconds ago.
Right. So that's the tag. If we could see all of them here. That's the image, and then that's the tag for what we pushed. So now anybody can go to that machine and pull that down.
They can go to any machine,
super interesting.
People at home could come and pull that now, right?
They could.
Yeah.
They can go look at Hello World.
They could go Docker pull Steve Lasker /Hello World :.NET Conf.
That'd be all set.
Yeah.
All right, so the push, and obviously I had to log in. That was done previously. So a bunch of more commands, right? More syntax, trying to put some more context to all of this. with search, pull, login, build, tag, and push, right?
Yeah.
So those are all general commands.
Cool.
Networking.
Wow. Okay. Yeah.
Yeah. This is one of those sharks.
Okay.
We'll cut this short and just say that inside of it, there's some very cool stuff on how all the nodes are set up in a private network. To get a container to reach out of that, it needs to actually have a hole poked in the, you kind of think it was a firewall. It's not really a firewall, but it's a boundary because each one of these by default are not publicly accessible. It's accessible by the host's IP and a port that gets routed. And we'll see that in some demos here in a minute. But definitely some interesting ones in here to people play with. But we've talked a bit about layers. Layers are a really cool concept of Docker to save in perf and deployment and changes. Imagine instead of having, if you want to update your app, let's just say SQL Server to version 2, I don't want to do an update in place of everything I have, or I want to apply a service pack to the host OS. Instead of having to apply over, I basically have this build order that actually can build up and it rebuilds that layer. So I don't have to actually uninstall, I don't have to start the VM from scratch. It's just this quick definition of each one. And each one of those steps is saved as a separate layer. In fact, you can see this a bit in the layers IO. And we're looking at 2 of them here, where you're looking at the RC2 core base image and then the Hello World app. And if you notice, the images are all the same up until we set the working directory, copied our app in, and sent the entry point. So when I have these 2 on my machine, I actually don't have twice as much of the whole thing. I only have just that delta for my app.
Cool. So it's similarly like if you're going from .NET, then all the instances running on your server that go from .NET are going to share that .NET base image.
Yeah.
Right?
Yeah. So I get a lot of savings in both, and network deployment as well.
Cool. Yeah.
Cool stingrays.
Cool stingrays. Right.
So persistent storage, as you mentioned, there are, we think about it as immutable, which is awesome because I can deploy stuff out there. I deploy a new one, the other one just goes away. But you don't want to be putting important data on that container because not only do they go away by design, it is a fault tolerant boundary. So if you have anything you want to save, you want to get it off there. You can obviously use PaaS services like SQL, document DB, all kinds of different PaaS services to get them off.
So volume mapping, so this persistent storage you're talking about here, volume drivers, is basically letting you save files to the host.
Well, that's one thing. There's volume drivers. By default, you can save things to the host. That's what a typical volume mapping would be. But there's volume drivers that I can go to like Azure Storage, Azure Files, and other ones that are doing there. So lots of cool things there. There's a quick example here. We'll save a little bit of time. So we can get to things like publishing, for instance.
Yep. Cool.
Very cool stingrays in here. The one thing to be aware of if you're using VirtualBox, by the way, which is what you get when you use Docker Toolbox, it's a little finicky in addition to the Hyper-V issues. So you definitely want to look for the Docker for Windows beta. That is coming. It's available privately now. Just make a request of here. If that doesn't, they're pretty good about getting back to you quickly. If they're not, ping us on Twitter or something, and we'll see if we can help you get in. But that'll be opening up publicly soon. A little bit of sharks in VirtualBox, which is why they're building the Docker for Windows beta.
The private beta, yep.
So we covered a bunch of commands with run with volume mapping is what that was about.
Yep.
So we have multiple hosts.
Mm-hmm.
How do you deal with that? Like we're talking locally, we've been running Docker against our local machine, but you might have Docker on another machine that you're trying to, might be running in Azure. You have a dedicated VM that you're doing your build agents on. Using Docker machine is how we used to communicate with those hosts. You would provision a host with Docker machine because it sets up all the certs for you, and it stores the directory locally. So it has those certs separate so I can switch between machines. We used to have in our UI, in our Visual Studio UI, how to provision that. Amit in the Azure team updated the Azure driver and how it's like this one-liner. It's so simple to provision a host.
Right. So this lets you create a VM basically. This particular line now lets you create a VM on Azure, and then you can point your local Docker CLI to that machine, so that when you go Docker pull, it's actually pulling it to the machine in the cloud. And this is how you would do that. Cool.
So this is how you create it, and then when you switch to a Docker machine env, the name, and it gets there.
So those playing along at home can do this if they want to grab the
exactly.
slides.
The nice thing is for Docker for Windows Beta, you don't need this because they've hooked the local network. So that's what's really nice.
Yep.
So we'll get out of that one.
Cool.
All right, now I want to instance multiple services, right? The whole idea is microservices. I'm not going to have this big fat app. I want to break them up into a bunch of individual ones. How do you deal with that? So Docker Compose is, think of it as a composer that's organizing a whole symphony of lots of people working together. They have great analogies. They have great artists. They have great analogies. You just got to love them. And you can orchestrate, or not orchestrate in this case, compose, group together a bunch of images to work together as one. So let's take a look at this, actually. This is probably a better example just to look at.
So while he's doing that, there was a question from Freddie about how do I deploy an ASP.NET Core solution using Docker to a non-Azure Linux host. So you can do that via just getting any Linux host. If you create a Linux, if you want to do it on your local machine, the best way is just to go to the Docker website, grab Docker Toolbox, install it, and follow Docker's documentation. And then when it comes time to actually running your app, do from Microsoft/.NET in your Docker file when you're building your image, just as Steve done earlier, and then that'll get you the .NET base image that has stuff in it. But basically, for a non-Azure Linux host, just grab Docker Toolbox. Even if your local dev machine is Windows, Docker Toolbox gives you a VM with Linux on it, so you're using a Linux host. Yeah. Otherwise, get a Linux machine, and as long as you've got a new enough kernel, you'd be good. Get a Linux VM yourself or something.
Yeah, so when we're running Docker for Windows here, or Docker Toolbox, I have a Linux host on my machine.
Basically.
And it's in VirtualBox. It's a different VM. But anyway, we'll jump back to
Docker
this.
Compose.
So here we have Compose, and if we look at this, we see, and this is the version 2 format, a collection of services. And the first one I have listed is this web front end called just multi-service. And it references this image. I set up an environment variable that says here is the name, where the location of my API is. Notice I've got this web API name, and obviously that's not a publicly resolvable address. This front end, I poked a hole in the firewall with port 80. That's not firewall, the host rather.
Yep.
But notice I say it depends on this other service, web API. This other service is another image reference. This is my web API, and notice there's no firewall ports or anything open. I keep on saying firewall, host ports open. So this guy's not accessible outside of that host. And they're linked together because this name here, Docker Compose, knows to set up the resolver in its DNS to find this service. And we can simply do a Docker, actually hold on, no, I haven't done any other demos yet. So I can say Docker Compose up, and we'll do it -D to detach. So now it will spin up those two images, which I happen to have already had on my machine, so they were already built. So it just ran them. And if I say Docker PS, we can see these two running. And if we notice, we actually see it's running the .NET command, the DLL inside of it. So now if I come over here to our host, and if I just hit refresh in my browser, we're going to see the ASP.NET template come available here, and that's all fine and good, and we got a nice little about page. But I also have this customer web API where I've got the front end here, but the data is actually coming from my API service. So I've actually linked these two together.
Yeah, but you can't publicly access the data service. You can only publicly access the web app.
Correct.
Which is cool.
Correct. So now I've got a truly microservices architecture if I've got this separated like that.
Cool.
And I could update those images separately. They could be revved by different teams. They could use different stacks. All right. So Compose, we kind of walked through this, right? Do the call the host. It did the depends, pulled its dependency images down, built the image, and linked them together. So save those decks for you later. So now we're getting a little more, right? Now you need 10 web front ends, 8 API instances, 4 4 Redis cache, a database, and a partridge in a pear tree.
Who is that?
Yeah, I know. All right, I'm going to stop using these old references. All right, so how would we do all of that? To do all of this, we actually need load balancers in here. And this is where it starts to get pretty interesting because, well, how do I set all this up?
Right.
And that's, again, where Docker comes in really handy because I don't have these PaaS services I need to configure. I could, in my compose definition, specify something like hot proxy, and then it would link these two together. With container orchestration systems, they have these services built in
So you
as
could
well.
build something like a compose file that defines all those layers we just talked about and all the load balancers, and then give it to some orchestrator, and that orchestrator will take care of taking all of those containers that you said you wanted, spreading them across a bunch of machines and making sure they run.
Yeah,
Is that
absolutely.
basically it?
Because if I try to run all of those on one host, it doesn't fit. So
Well, we could just drag the box down, it'll be fine.
that's PowerPoint. I guess you can do that to your VM. So go to the little scroller and give me the monster, the Godzilla size.
Yeah.
Or we could be a little more practical and spread the load. And what we'll do is we'll take those containers and split them up amongst a bunch of different hosts. We'll put the load balancers in there. But now, well, okay, I've now had to manage all of this. I've got these things. How do I configure where all the hosts are running? And if one of them dies, the idea is that these other containers can be spun up on other nodes.
Right.
Now, I don't know about you. I don't want to get called in the middle of the night. Do you have a pager?
No, I don't have a pager.
The text version of pager. So this is where the concept of orchestration systems come up.
Right.
I am going to orchestrate where all these things go and do it in software. It'd be really nice.
I mean, a lot of these concepts are very generic. A lot of these containerization concepts we're talking about now are kind of generic across like Windows or Linux containers.
Absolutely.
Or like, Service Fabric does a whole bunch of stuff to make things like this happen for you really, really well as well. Right. You can see that some of the keynotes of Build, for example, recently where they showed applications and process things moving around, right?
Service Fabric is a great orchestration solution for managing microservices. It's a higher level abstraction, so it takes care of a lot of this for you.
Absolutely.
So it's a great solution for that. And then the idea of orchestration is it keeps them running. If one dies, it'll move things around. And the concept of a scheduler says, I am going to take on a load. I'm going to submit to you an image, and I'm going to tell you, keep it running.
Yeah.
And so that's what the scheduler does. It says, I have a collection of images. I will run them for you, either a task, do it once, or keep it running. And the orchestrator is the guy that actually keeps it running.
Okay, cool.
To do those, those are running as to other containers also in this cluster. And they manage all of that environment. Lots of cool stingrays, lots of sharks.
Awesome.
Lots of detail there.
Okay.
So we'll take a
breath.
Take a breath. There's a lot of stuff we just covered. Nice the relaxing time there. But we're out of time, so we're going to keep on moving.
Yeah.
All right, container workflow. This is the place where it gets interesting. You've got all these containers. Well, where does it really work in the big thing, big scheme? Because we don't really want to put code on a single host. The whole idea of being in a container is that I tell it to run this and it keeps it running. I like to think of it as it's kind of like using that driving a car like you ride a horse. It gets you someplace. It's still referenced in horsepower, but you really want to take advantage of the car. Don't want to have to keep feeding it. So the local development, we want to write our code, we run it, we debug it like we do today, because we actually want to run it in a container, especially if you're doing cross-platform. I will push source code. I don't push images. I push source code, and my CI system will take that code and build the container. Now, you can build it locally too, but we're doing it as a check. We really want the CI system to do this. So it'll take your Docker file, your base image, a compose, and it will spin up those containers, and then you can run tests against the collection. If the tests pass, then you can push your images to a registry, and you would trigger your CD, which, by the way, I like to think about as there's this brick wall here. We don't push code to deployment, we push images. So now we can say with Swarm, we can use Docker Compose. With Mesos and DCOS, there's a Marathon scenario. Marathon is a technology for that orchestrator. And now I'm spinning up those images, and the only thing that's different is the environment variables and the secrets that are passed to it, right? The image is baked, the binaries are tested. So that's kind of where we're getting at, is each one of those things ships with this environment. I don't need to tell anybody, hey, set up this service pack, set up this, detail.
So you can be confident that if it worked in test and it worked in staging, it's going to work in production.
Yeah.
You're not going to get the problem where you forgot to install the thing on the server in production, and so the production deployment failed, but your test and staging is fine.
Right.
And then your ops guy spends a week trying
to figure out those
not a week,
details.
but spend some time. And if you're in DevOps land, you can kind of make that better by making sure everybody knows what's going on. But in this world, it's kind of there, right? Like,
very cool stingrays.
cool stingrays, cool.
Workflow, source controlled, CI, and of course we've got some great products from Microsoft that help you out with all of these, including great integration with things like Jenkins and Git and so forth. We have VS Code and Visual Studio, which brings us to our demos.
Awesome. I like
So
demos.
let's take a look at some actual code here finally. So we built up all the primitives. Let's take a look at what this looks like when we actually have it all stitched together. So what I have here is an ASP.NET RC2 core app. Thank you, Glenn, and the rest of your team.
Yep.
And I want to be able to test this. Now, the way I've got this set up, I actually have some code in here that is different for Windows and Linux. And if it works great on my machine, which is a Windows machine, it doesn't mean it's going to work in production. And talking with some of our customers, we have some of the common cases. Obviously, file paths, lean forward, lean back. It's kind of like a Harley or a sports bike. Or for volume mapping, files, case sensitivity on files, date time zones are different, things of that nature.
Yeah, it's just the general problems you hit when deving on a different operating system to your deployment environment.
And even we see this sometimes in IIS and IIS Express, right? We always have some
absolutely. The same problem we had. Like, this is why we ended up with IIS Express and not the Cassini, some of the older ones that we had, which were very different.
We did get closer.
Yeah.
So here, what we can do is say add Docker support.
Now this isn't there on my Visual Studio, right? Unless I do something.
Right. So this comes with our Docker Tools extension. We'll put links at the end. But with that, you can get the Docker support. And we're revving this pretty frequently to kind of take feedback and take some changes to continue to iterate on this. And by doing that, we will get the Docker assets to my project. So notice that we have the right name in there. I didn't put the second colon by accident.
Excellent.
We set up the environment variable that you need to open up, not Kestrel, open up the app so Kestrel can route traffic to it. Copying the app and setting the entry point is all set up here. We have a debug version of that so that when you're testing on the inner loop, we'll give you the debugger and we'll set up volume mapping, which is set up here, so that now what we can do is actually make changes to our code locally without having to rebuild the container each time.
And then it'll be running inside a container though, so you're verifying that it's going to work on Linux on your dev machine, even though your dev machine is not Windows. So this is kind of making it so that you've got like a really cheap, nice, fast, local Linux VM, almost. You're treating the container kind of like a VM in this case, in order to be able to just test your stuff on.
Exactly.
As you dev. Yeah. Cool.
So by adding Docker support, we added a target. In addition to IIS Express, we now have Docker. So I hit F5, and now I am building my app, doing all the steps that we showed earlier with VS Code, and I'm going to build and run that in a Docker container. And as I click around, of course, we're running, if we notice, because I'm using Docker for Windows, the beta, you can see the URL.
Yeah, the Docker URL, yep.
And if I click on the About page, we'll notice that I just got breakpoints.
So what's happening here? Let's take just a couple of seconds. You have on your machine a thing called Docker for Windows, which is running a Linux. It's basically running a Linux VM, which has the Docker daemon on it. You're inside Visual Studio on your Windows host, and you are pressing F5, and that is building an image for your application, mapping back to the source code. It is starting that image on Linux, and then opening a browser on the host, browsing you to the URL for your web application, attaching a debugger from Windows into the Linux machine, and then hitting a breakpoint and halting execution and letting you inspect the state of your .NET application running on a Linux machine on your Windows machine. Is that right?
That's right. That was quite a list.
Yeah.
Yeah, you understand why we've been a little busy and why you don't, you can certainly do this yourself, but it's pretty tedious. There's a lot of details. And you can see we're getting, we're hovering over, we get environment variables, we can see the information, we can inspect it. And as I run this again, we can see
Hostname here is an environment variable that Docker sets inside the machines, inside the containers, so that with the ID of your running.
Right, and notice my OS description. I can see it's Linux. I can see it's .NET Core.
Yeah.
Right, yay. So why not .NET Core
Cool.
4?
Hey,
I don't know, do I want to poke at you around what?
Let's just
Just move on, okay. That's all fine and dandy. But now, let's say we want to make a change.
Yeah.
So what we're going to do is, we saw a breakpoint. We were able to breakpoint debug, but now I want to make a change. I'm going to rerun this in what we call Control F5, like the detached mode like we would do with IS Express, right? And now, by doing that, not hooking the debugger, because the debugger locks that process, what we're going to do is spin that up again, but we're going to use the volume mapping feature, and if I come over to the About page, which we can say, all right, so there it is. It's About. Notice my breakpoint's not getting hit this time. And we can say something like, here we are at .NET Conf. And if we save that, by saving it, what we're doing is we're updating the binaries here. And this is a short thing we're doing. Are you smirking at me?
Stefan, yes, it's an amazing Doctor Who graphic on my laptop. Thank you very much.
Yes. And we can see the questions here. So
I
little
bought it from Amazon.
squirrels.
You can go look for it.
Anyway, so we made a change, and now if I come over here and I refresh that, I didn't have to rebuild the container. What we're doing is we're using the volume mapping, and we rebuild those DLLs. We took a shortcut for RC2. We actually are doing the build and publish because we know we needed that for release.
Right.
We had a bit of an issue, but we're going to go back to probably going to do a restore scenario in the container for during development.
So you said that earlier. You said earlier the flow that kind of our Visual Studio tooling is. That you're kind of suggesting with all of this flow, though, is that we don't push this image, right?
No, right now I am running everything local, right? I want to test it. I want to make sure it works. In fact, I can even switch over to the release version, and now I'll get this Docker file and this compose file, which doesn't have the debugger. It would use a thinner image.
Because you need a thing running that's listening for the Visual Studio to attach inside your container if you want to debug. So you don't necessarily want that running in your production site, right?
Right. So there's so I can optimize that image. I can test it locally, but the idea is I want to check in code and have the source code, the CI system build it. So we made that change. Let's come over here to GitHub here, and it works on my machine. We see the little change we've made. And so what I'm going to do is do a push for .NET Conf. We'll commit. We'll sync. And I've got a branch here that I've got that triggered off of. And now if I come over to here, what we'll see is in VSTS, we've got our build system. I did do a check-in, right? Yeah, there we go. Oh, there it is. And so now what we're doing is we're flowing through those build steps. We're doing the .NET build. We're doing a .NET publish. We're doing a restore in there, sorry. Doing the publish, so we have the binaries. And then we'll do the Docker build. We're going to do tags, so we actually tag it the build number, so I can see the builds, and latest, assuming our test completed. And then when all that is good, we'll actually push those images out to Docker Hub. And because I could push to a private registry, we just didn't set that up for this demo. And then I'm going to tell ACS, our Azure Container Service, to update your app with the image that I've provided. So that's finishing up.
Nice.
Let's see where it's at this point. It is telling Swarm in this case, because Azure Container Service can run Swarm or
would be the
DCOS.
orchestrator that would, in this case, is the orchestrator you're using. So Azure, we kind of briefly mentioned Azure Container Service there. So you have a cluster of machines running on Azure, running Docker Swarm, which is an orchestrator that orchestrates pushing containers out to multiple machines, or taking images and running them on multiple machines. And so when you commit code, it automatically detects that you've committed code, it builds the images, pushes them to a registry, and then Docker Swarm picks up the fact that a new image has been there and then deploys it to the machines.
Yep,
So right,
that's
and Swarm is, and you can go and make an Azure. If people wanted to, they could go do all of this today with this stuff, right? Like Azure Container Service, you can go make one now, and you can try out the private.
Just
It's a
go to
preview. It's
the
in preview,
Azure.
but it's a thing,
Actually,
right?
well, no, they went GA.
Oh, they
Azure
did?
Container
Okay.
Service is
Awesome.
GA with Linux. We have Windows coming. We have a private preview on Windows, so if you're interested. And then we can see this is now running out on the Azure Container Service.
Cool. So everybody should like hit this now and try and bring it
Yeah,
down for you.
they can do that if they want. Hopefully this won't be one of the Hanselman demos where we
fair.
get thrashed and the map completely fills up. And if we look here, we can see, here's our little text that we updated
We
out
added
there.
earlier one that we committed, and yeah, cool.
So pretty good, big sweeping end to end there of what we've done here. Let's take a quick recap. So we have the Azure Container Service. Great way of doing microservices. We think of the stack of, we have VM scale sets, roll your own, build in your own car, right? You've got complete control. We got the Azure Container Service when you want to work with your apps as deployed containers and you want a lot more control. We have Linux support there today in GA and Windows support coming. And then as a higher level, we have Service Fabric as a way to do we kind of think of it as a microservice engine. And where we will handle more of it for you. So you have a lot of functionality, a lot of discovery services, and a lot of good CI, a lot of great tools. They're set up for that. And it's a higher level abstraction over Docker containers, over the Azure Container Service. As you mentioned, Azure Container Service is an ARM resource, so you can go to the marketplace, look up Azure Container Service, and configure that. And you get a choice of Docker Swarm or DCOS. What else? So, do we want to test everybody in the audience on?
I don't think so. They
No?
don't. Like,
They don't think they want to do that. Nobody really likes taking
can't
tests.
see anybody putting their hand up saying they want to do it. So
Okay.
all right.
All right, so coming into port, we have a whole new vocabulary. We kind of talked about the container workflow to think about the subtle but very important changes is that you're not deploying code, you're building an image, and that brick wall kind of separates where your code is to an image. So in production, you're never building images, you're deploying images that are built from more than likely your private registry you've spun up.
Yeah.
We've got the products. You got Docker Toolbox, which uses VirtualBox, and we've got Docker for Windows, they have Docker for Windows, Docker for Mac. It's basically from Docker the way to do host Docker locally.
This would be the alternative to Docker Machine that you get today with Docker Toolbox.
Yeah, exactly, and in a much better integrated way. So it actually uses Hyper-V, so I don't have to disable Hyper-V to use VirtualBox. So there's a bunch of links here for some of the tools. Docker tools for VS is what we've demoed. VSTS is the build steps that we breezed through there. VS Code extension was some of the language syntax for Docker files. YoDocker is a way to scaffold out these assets. And I've just got links to the presentations and the repos for the demos that we've done. And of course, the Azure Container Service and Windows containers.
Cool.
So
Excellent. That's
quite
it.
a whirlwind tour there.
It was. I mean, I assume that most of the people watching didn't know a great deal about Docker. That was kind of our assumption coming into this.
Yeah.
So we kind of jumped all over the place to try and give people as much of a
big swath,
a big hit of it. But if you want more information about any of the pieces, feel free to reach out to us, and we'll try and get you what we can.
Yeah, we'd love to get your feedback on what's confusing, what you like, what's missing. We have been incorporating a lot of feedback in the tools. In fact, one of the things you'll see, like this Docker task that's in there, was because we got a lot of feedback that our early on publishing experience was very cool, but too structured, and people wanted to switch things out. So that's the kind of feedback we're looking for, and love to hear from you. So with that, we'll wrap up. And who's up next?
I'm actually not sure who's up next.
Okay, well,
sorry.
Look down below.
I should know who's up next, but I'm
and
assuming it's
see.
on the website. So
Thanks
thank
again.
you for watching.